Okay, so we're talking about light, and light is the same, has the same kind of properties as sound, right? But it's not the same thing. Yeah, got it? Okay. So light travels in a straight line. That's kind of important, okay? It travels in a straight line. When you do your problems, there's going to be a reading for the first assignment, and all you have to do is look through that reading, and as you're reading it, answer the questions. Okay. It travels very fast, around 300 kilometers per second. That's pretty fast. At this speed, it can go around the world in 8 seconds. So light is a lot faster than sound even. It travels much. Oh, there, look at that. I'm ahead of myself. So thunder and lightning at the start, they start at the same time, but we see the lightning first, right? And then you hear the thunder. And do you guys know, like, once you hear or see, sorry, once you, yeah, see the lightning, if you count before the thunder, you can tell how far away it is, right? All right, and then when you see a starting pistol, it's fired, you see the smoke, and then you hear the bang. So light travels faster than sound, much, much faster. So we see things because they are reflected into our eyes. So the sun reflects off of a piece of paper, and that reflects into your eyes. And not only the sun, light is also reflects into your eyes. Okay, so this is what I want you guys to do for me. Type in chat box, whatever this is, Notepad, sorry. A luminous object is one that produces light, and a non-luminous object is one that reflects light. So I want you to just type in there, just think of 4 things that produce light and 4 things that reflect light. Type it in your Notepad. So luminous is producing light. So what produces light? Okay, a couple more. Think of like 1 or 2 more things. Paul's all done. Looks like Karen, are you all done?
Did you find a lock for our boxes yet?
A lock?
For the boxes?
Oh no. Oh, maybe I'll ask Mr. Roth. He probably
A lock
knows.
for what?
Box.
So that other people can't. We played a game last week. Not last week, but the week before. And people were messing up other people's answers.
Whatever that dude is at Central is writing in everybody's box.
Okay.
He deleted everybody's box over here.
All right. So luminous objects. What are things that produce light?
Solar panels?
Flashlight.
Flashlights. Solar panels, do they produce light? They absorb light.
But they produce it because
They
you
produce,
can use the energy off of the solar.
right, they produce the energy. Okay, so we had candles. Karen?
Phones.
Fires.
Fires produce light. What else? Phones? How do phone? Oh yeah, when you open up your phone, you see the light bulb. There you go. Okay, good. What else?
Computers, TVs,
Camera.
microwaves.
Mm-hmm. What about the biggest, most important thing?
Sun.
Yep, Sabrina has it down here. Sun produces light. Now, light bulb produces light, candles, fire. Okay, you guys got all those. What about things that reflect light?
Mirror.
Glass.
Mirror,
Those
glass,
little prism thingies.
little prism thingies. What else?
Eyes.
This table reflects light. You get the light from the light bulb, it comes down to the table. Some of it is absorbed, and the stuff that's reflected is why you see the brown or whatever color you think this is, red, whatever it is. Okay?
Light reflects on your eyes.
Those sparkly thingies when you're like in the car or something and like they flash.
Oh yeah, the little like kind of look like disco ball things.
Mm-hmm.
Yeah. Okay, so those are things that you need to think about. Things that produce light and things that reflect light. Because when you reflect light, that's when you see colors. Like Morgan's sweatshirt there, it's red, right? Does everyone see red? Making sure I'm not like crazy here. Okay, so what's happening then?
Blue.
Say again?
I see blue, purple.
Across the top. Okay. Excuse me, but what's happening is the light is shining down, right? And it's absorbing all the other colors and reflecting all the red. So that's why you see the colors that you see. Make sense?
How
Okay.
does that work with neon?
Hmm?
How does that work with neon?
Neon's specific color.
I mean, it is, but like if you have a neon light in the room and like somebody walks in with a shirt color, it turns to a dark color or a light color.
If you're wearing white.
Oh yeah. I don't know. That's a good question. I'll find that out. That's a good question,
Like if you
Paul.
go to Skate City and they're skating and it's dark, if you have a light shirt, it'd be like a whiter color, and a dark shirt would be like a grayish.
Is that neon or is that a black light?
It's neon.
Is it neon? Okay. I don't know. I'll have to look at that. That's a good question. Okay, so shadows are places where light is blocked. So, like you guys can hold your hand over the table and you can see a shadow because your hand is blocking the light onto the table, right? That's the same thing for shadows that you see light poles and everything else. This tree is blocking the light, so that's why you see the shadow. Now, how would I change, let me go back there real quick. How would I change the size of this shadow? How can I change it? What if I made the tree bigger? Would that make that shadow smaller or larger?
Smaller.
Why would it make it smaller?
It's kind of, I don't know what to say it's like, but the bigger something is, like the shadow will be smaller.
Okay.
Like if you notice, like say for instance your computer,
Mm-hmm.
the farther away that something is, it'll show the reflection a lot better. Will the sun, like if sun's close to the tree, it'll probably be a lot bigger.
Okay, so it's not necessarily the size of the tree, but the placement of the light, right? So, yeah. So if the way the placement of the light depends or makes the shadow either bigger or smaller. That's why shadows change during the day. An object doesn't change its size, but if you think about it, a light pole, the shadow changes as the sun goes from east to west, right? So it changes, and it's not the size of the thing that makes it change, but it's the placement of the light or the sun. Okay, so let's look at some properties of lights. This is important. It travels in a straight line. It's faster than sound, And we see things because they reflect light into our eyes. Shadows are formed when light is blocked by an object. Okay, these are things that are important, and the reason that I say this is because as intuitive as you may think they are, they're going to be on the test. Okay. Putting that out there. Okay. So let's talk about a little bit about reflection. So here's a mirror. This line is called the normal line, and a normal line is always perpendicular to a surface. Does that make sense? What does perpendicular mean? Say again? It goes straight through another line, like at 90 degrees. Yes, okay? So the thing that's important here is that it makes this 90-degree angle. That's what normal line means, okay? So we have some light coming in. This is called the incident ray. And then we have light going out, or that's being reflected, and that's the reflected ray. The angle that this incident ray makes with the normal line, or that line that's perpendicular, is called the angle of incidence. The angle that the reflected ray makes with that normal line is the angle of reflection. Makes sense, right? These things aren't, this isn't rocket science, but well, maybe it is, but the lower levels of rocket science, okay? It really kind of is, guys, so, you're learning rocket science. Okay, so let me go back here real quick. So the main thing that you have to remember here is that the angle at which light comes into a surface or a reflector or a mirror is the same angle that it's going to be reflected out. Does that make sense? Okay, good. Okay. What is this? Angle of incidence is equal to the angle of reflection no matter what it is. No matter if it comes in at 20 degrees, it's going to go out at 20 degrees. This angle right here is equal to this angle right there. Okay, so we're going to fill in some missing words. In other words, light that gets reflected from a surface at some blank blank angle, it hits. Okay, let's read that again. Rewind. In other words, light gets reflected from a surface at blank blank angle, it hits it. Okay. Light gets reflected from a surface at it gets reflected from the surface at, so comes in, it gets reflected. They get reflected at, no, it's not a specific angle, it's the same angle. Maybe that's poorly worded. I don't think so. Okay, so what this is saying is that the angle at which it comes in, light comes into a surface, it gets reflected out at the same angle. Make sense? Makes more sense saying it that way. I'll have to remember. Okay, so the words that we were looking for is the same. Okay, clear versus diffused reflection. So smooth, shiny surfaces have clear reflections. So if you look at a mirror, it's pretty clear that you can see yourself, right? What about those kinds of mirrors that are not that make you look weird and ugly? I'm not thinking about those. I'm thinking about the ones kind of like, have you guys ever been to a rest area? Like when you drive long distances and you stop at a rest area. The mirrors at the rest area, are they ever really clear? I've never seen.
Like someone punched them.
Yeah, they kind of look wavy, or they look kind of like a bluish color or something. So those are things that are going to get diffused reflection because it's not smooth and it's not shiny and it's not
I only
clear.
saw one that was.
Yeah.
That was at, I think it's called Quick Trip. It's in Texas. We stop there every time we go to Texas.
Oh, I used to travel a lot in Wyoming, and they never had any nice clean mirrors. Theirs were always kind of diffused. So if you have a clear shiny surface angle that comes in, the light is going to be reflected at the same angle going out. However, if you have a rough or a dull surface, then the diffused reflection is when light is scattered in all different directions. So that would mean that this is what a diffused reflection kind of thing is going to look like. The surface is very rough. It comes in at one angle, goes out at another. They all come in, the light comes in all at the same angle, but it goes out at different angles because the surface is really rough. So it's going to hit that surface at different places, and then it's going to hit it, and it's not going to be smooth. So it's going to diffuse or reflect out at a different angle that it comes in. Okay, so the only time that you get the angle of incident equaling the angle of reflection is when you have a smooth surface. Does that make sense? Okay. This comes in and out at all different angles depending on where it hits the surface. Okay, this is just a little bonus because it was such a short. You guys know about telescopes, right? Or periscopes, like things that they use in submarines. Well, this is how they work. They have two mirrors in there, and what happens is light gets reflected, it comes in. Where's my little thingy? I don't know. Okay. If you're looking out, you look into a mirror, then that light gets reflected straight up, and you look out at a boat or whatever you're looking at. Or here's the boat, and again. So it's coming in at 90 degrees, it's being reflected out at 90 degrees. Does that make sense? Because these are mirrors, these are clear surfaces. Car headlight. The car headlight isn't a flat surface and it's not clear. It's a curved surface. So that would mean that light, when it's reflected in, it's going to be reflected out straight back. Okay? Curved surfaces are a lot different than flat, mirror, straight surfaces. And we're going to learn about that next week. Okay. One last thing before we go. Here are your words. Put them in there. Refraction is when waves blank, or slow down, speed up, okay, due to traveling in a different medium. All right, a medium is something that waves will travel through. When a pen is placed in water, it looks, this is like kind of when you think about like a glass of water and you put a straw in a glass of water. If you look at it from the side, it looks bigger and it looks like your straw is broken, right? So that's refraction. Okay, next. In this case, the light rays are slowed down by the water and are bent, causing the pen to look odd. The two mediums in this example are air and water. Okay, so that's just kind of another property of light. It looks like it can bend things. So it's kind of cool. Okay. And that's it. This is just pictures. You guys are talking about prisms that are reflectors, and that's true. All right. So that's it. Main thing is you guys make sure that you know those properties, right? And the final in a couple of weeks is going to talk about refraction and reflection and all that. All right, just a minute, let me stop.